When I was an undergraduate, I was studying chemical engineering, studying about, petroleum refining and chemical manufacturing and things like that. And I realized that I wanted to focus more on the natural environment, the chemical reactions that are occurring in the atmosphere, and how things are transported throughout the atmosphere. But at some point I started to realize that no matter how environmentally conscious we were, if we didn't address the insatiable demand that we have for energy and for water and for manufactured goods, we could never be sustainable. No matter how environmentally benign or environmentally conscious you are, if you have an insatiable demand, that just can't be sustained. So at some point I started thinking, what is the long-term trajectory? Where are we going with our water systems, with our energy systems, with our manufacturing systems? And what is the long-term future for our society? And that really triggered my focus on sustainability. The first is our outdoor air quality work. We do a lot of work understanding the source of ambient air quality and the pollution in the outdoor environment. So this is one of our ambient air quality samplers. What these samplers do is they pull air through a filter. That filter collects the particles that are suspended in the atmosphere. The reason that we do this is we want to take the particles that are suspended in the atmosphere, collect them on the filter, return that filter to our laboratory where we can do a series of detailed chemical analysis to figure out what the chemical composition of these particles is. Now, the reason that we do this is understanding the chemical composition is vital as far as determining what the original source of those particles was. So if we want to reduce the ambient particles in the environment, we figure out what sources are contributing, and then we go and control those most important sources. So this type of work is vital for environmental regulators to understand which sources should be controlled and to develop effective control strategies. So one of the reasons we're most concerned about these particles is obviously if they're in the ambient environment, people are going to breathe these particles in. When you breathe these particles in, they interfere with your respiratory system, they can trigger asthma attacks or worsen existing respiratory disease, and they also give an additional burden to your cardiopulmonary system. They lower your lung function, which makes your heart work harder to pump oxygen throughout your body. So it's a real health concern, and controlling these particles is very important towards human health. So the second project deals with indoor air quality. And with a lot of focus on energy efficiency retrofits, we want to understand what the effect of energy efficiency retrofits is on indoor air quality and health. And what we're doing is looking at the before and after air quality in a building that is undergoing an energy efficiency retrofit. Because often these retrofits seal the building envelope, keeping the hot air out and the cool air in here in Phoenix. And so it's important to understand whether those retrofits trap indoor sources of air pollution. So what we're doing is we're measuring indoor air quality at an apartment complex for seniors. And we're concerned about seniors because they're some of the more vulnerable members of our population to environmental burdens. So what we're doing is we've done sampling in 72 different apartments at a senior apartment complex before the energy efficiency retrofit. The retrofit is going on now, and we're going to do indoor air quality sampling after to see if sealing the building envelope affects the indoor concentrations of pollutants. At the same time, we're most concerned about the health of the seniors, and so we're working with the College of Nursing and Health Innovation here at ASU to do a health survey, which will be administered, again, before the retrofit and after the retrofit, so we can figure out what link there is between indoor air quality and their health, and whether the building retrofit has had an impact on health. So instead of using the big noisy pumps that we use for ambient air quality sampling, we're using these portable sensors, and we're deploying these at different locations throughout the apartment complex to figure out what the indoor and outdoor concentrations of pollutants are. It's vitally important to understand the role of energy efficiency retrofits on indoor air quality. For example, right now in the Global Institute of Sustainability, we're working with the City of Phoenix on a $25 million project funded by the Department of Energy to promote energy efficiency retrofits. So we have to better understand the role of energy efficiency and sealing the building envelope on indoor air quality, because it will directly affect residents' health. When I think about sustainability challenges, the one that I'm most concerned about is climate change. And when I think about climate change, you immediately think of our energy systems, because our energy right now is linked to fossil fuels, and we need to have energy to continue to provide a better livelihood for people across the globe. But climate change is more than just energy and the atmosphere. It's also the other systems, such as water and our food systems and how we build our cities. All of these have to be adopted in the future to mitigate climate, and that's what concerns me the most.